Hello. Good morning, everybody. Hello, hello. Anybody home? Oh, great. I see William.
Yeah, I can hear you.
Okay, William is in the chat room. Anybody else? Let me see. Okay, can somebody here respond respond to me whether my voice is it clear? Is my voice clear? I'm in different room today, mainly because somebody downstairs making noise. So I want to be in my home office upstairs, and because this room has a bamboo floor, and oftentimes I can hear my own echo, and so I don't want to cause any interference to this microphone speaking with this echo. Am I okay? Am I okay with the quality of the sound?
Yeah, there's like a little bit of an echo, but it's not bad.
Okay. To be honest with you, I can hear echoes from students too, because some of from during the past 3 days, I noticed, yeah, students from different room, yeah, may also cause a little bit problem, um, and also because I believe it is something to do with the traffic on the internet. Okay, so the recording 2 days ago during the conversion of the file. Okay, so at the end of the meeting, the file of the recording will be converted to the MP4. And during that conversion, I guess the signal didn't really go through. So I have problem uploading it. So whatever recorded 2 days ago cannot be uploaded. Okay, so but I realize it is probably not a big problem because we will have discussion session today one more time. You're welcome to ask question. The Monday recording already covered our peptide experiments, part 1. And so if you have question about Aldol report writing, please ask today, okay? So far so good. Are you able to handle the Aldol reports? By the way, did Dr. Lopez write to you about his decision on, let me show you this part. So let me see how many students I have here. A total of 11. That's perfect. Okay. I want to show you this. This is, oh my goodness. One more time, I need to go back, okay? Minimize. So it is this 420. this page, I want to show you what got me confused. Right here. This is the Aldol report instruction. On page 30, you know you will be required to write the report in the formal report format. Okay, because it is instructed right here, please follow the format of a paper published in the JOC, okay, with Journal of Organic Chemistry. Now this is the highly respected journal in the organic chemistry, and we want you to follow the format. I can tell you there is a special format how you want to present IR writing. No, IR peak assignment, okay? There is a special format for NMR as well. Okay, so it's no longer giving me a table with boxes. It's not like that, okay? It's another way, professional way to present it. And we want all of you to check the format. Look up online, okay? Any article from JOC will give you the idea, okay? Okay, now this is one requirement, and look at the other requirement. A data analysis report sheet will be completed in lab, okay? I don't know about this part, okay? I don't have this data analysis report sheet, and I don't know about Dr. Lopez's decision, how he want to proceed with our current setting, understand? So I would ask all of you to chase after Dr. Lopez. He didn't respond to me, and I don't know his decision, and only you can verify with him during the lecture, okay? Is everybody here? So it seems to me Aldol report has two parts, okay? The format that you need to follow with report writing, that's one right here, okay? And the other one is the data analysis, okay? So I don't know what he wants, okay? And the other thing is, by the way, are you able to handle Newman projection, etc.? Can someone respond to me? Anyone having problem, would you please reply back? And maybe you can help me clarify. Hey, I don't hear anything. Let me check your remark. Maybe some of you are typing it. Hey, I don't see that bar. Do I have to do it this way? It seems to me I have to go back to the Zoom page. Right here. In order to get that bar. Is that right? Hello?
I'm not sure how Zoom really works.
Oh, usually when I put my mouse in this area, I will be able to see the bar. Oh, right here. This is okay. Let me see if you guys are typing any answers. More chat. No one is giving me any input. Can anyone here type and respond to me? Maybe I cannot hear you, but are you able to handle Aldo? If you don't respond, I assume you all got the message. Okay. All right. So let me know if you have a question. Okay. Today my plan is to.
I have a question on the Aldo report. Since we didn't collect IR data, should we like get IR data from somewhere, like a journal
Oh, the IR. Let me see. Is this required?
It's told to collect the IR, and then in the report it says to analyze the IR and NMR spectra.
I can tell you because we never really had time to take the IR. And if we don't provide you from instructors end, we don't provide you the IR data and maybe from the previous years, then you are exempted. I mean, you don't have to write anything along that line, okay?
Okay.
Report. Is that okay?
Yeah.
We understand, okay? Okay, and let me see. So can I cross this? Yeah, maybe I can do it without this at all. Okay, let me do one more thing, okay? So please make sure you check with Dr. Lopez about this report sheet, okay? I have no clue whether we want to proceed with another report. Okay, now look at the this reaction again. Okay, I want to just touch up your understanding from last conversation. I believe I talked about the optical rotation, right? Did I talk about the optical rotation? Hey, silence. That means I didn't. Okay. I want all of you to check the photo. Okay, check the photo because it's actually a matter of dissolving the compound in the proper solvent. And right here, okay, we have something like this. Okay, in the procedure, you're required to obtain a specific rotation for the L isomer. Okay, now why don't I just make sure you understand what this L means. Have you had the education from the either biochemistry introduction level, what L and D or L is? Okay, if you don't know, okay, this is, I need to do this. I need to give you my handwriting. Okay, let's see. Where is it again? Right here. Start video. All right. Are you able to see me? William, are you able to see me?
Yes, we can see you.
Yes?
Yeah.
Okay. Are you able to see my handwriting?
Say yes.
Yes.
Yes? Okay. Okay, you all know about this stereochemistry. You learn about R and S assignment, depending on the ranking of the substituents on the carbon. And you know the largest group, you gave the highest ranking, and then you can determine whether that 3 groups besides hydrogen, you can determine whether the R means it is a clockwise ranking when the largest to the smallest is clockwise, and then the counterclockwise will give an S assignment. That's all arbitrary assignment if it is just a simple small molecule. Now with the DNL assignment, it's more for biological molecules, okay? And let's say for sugar, the sugar, okay, has carbonyl group, okay, and has OH group, Alkyl group, we have this Fisher projection you learned in the past. You learned about Fisher, right? Fisher projection. And we want to give the D assignment or L assignment based on the lowest hydrogen on the carbon, the lowest. Okay, if it is on the right, then you call it D. If it's OH group, it's on the left-hand side of the Fisher projection, then you call it L. Okay, this is for sugar. How about for amino acid? Are you able to see it? Okay, then we target on the NH2. Okay, again, you put the carbonyl group on top, alkyl group on the bottom. Okay, for any amino acid, if the amino group is on the left-hand side, then you call it L. If it is on the right-hand side, then you call it D. Okay, okay, so we go by this assignment for the biological molecules, okay? And so let's go back to this lab manual, okay? We said the literature value for the L isomer of the product, okay, of the product. It's either L or D, okay? We give you the literature value of the L, and when you take the optical rotation angle, okay, the L gives you 46.5 degrees of rotation. Now, you know, when the light comes in, it bends. And when I say it comes into the molecule, okay, because the light, the D line of the light enter the molecule, it enters the molecule and then bends in with an angle. And it all depends on the stereochemistry of this compound you're producing, okay? The compound can bend to the plus angle, meaning, you know, it's all coming from a machine. If it is if it is a clockwise angle compared to the, you know, the opposite direction, you will get, okay, you will get this angle depending on whether you have an L isomer or a D isomer. Okay, and so I want you to learn from, okay, the photo chapter. You know, I don't think I need to spend time, you know, just showing you how we push the buttons, okay? Preparing the solution itself, it's very tedious because it's really hard to dissolve the compound, okay? And usually it takes, oh my goodness, how many hours of shaking. In fact, I just asked students to prepare the solution in volumetric flask, okay, in 5 ml size, and then shake and shake and shake, and it takes, I'm not joking, one time it takes 1 to 2 hours, okay, for students to just, you know, rotate between groups to make it dissolve. And yeah, it's very tedious. And I want you also to look at, you know, the definition of 2 right here, definition of 1, okay, depending on which solvent you pick to dissolve it. And
Milk is the best character in the entire series. So as you all know, in City Folk, Sable tells the story of how she used to be best friends with him, but he ended up leaving to pursue his dreams of being a successful businessman.
Mariana?
And to be cheated out of every doll that he owned. Through his amiibo card and Happy Home Designer, you can actually find out that it's Crazy Red that does that, because he says, "I'll never work with foxes."
Hey, who's playing this music?
These games.
Huh?
You can mute people.
Oh, I can mute people. I see. No, I cannot mute people. I can only mute when it is absolutely necessary, because I still want to hear from you though. Okay, and so let me tell you this, okay, the definition of 2, okay, right here, it is just concentration unit, okay, and go ahead and find out how we do the calculation when we prepare the sample, and then how this specific rotation is being calculated. Okay, it's all in the photo chapter I have already posted, okay? And this is the solvent we actually select okay, for that particular measurement, and then this is the angle. Okay, so most likely, because L isomer is being listed, so I'm assuming, and without the D isomer reported here, so I have a feeling it is the same angle of a rotation, but it's only opposite sign in the direction. Okay, if it is not reported with the other isomer, that I will assume this is the case. Okay, and I remember when my 420 students determined this number in the lab, we got very, very close number. Okay, so what I want to tell you here is, okay, you know about this D and L assignment, and tell you what, this D and L is also arbitrary assignment. Okay, it's all human assignment, but whether it predicts the direction of the optical rotation, the answer is no. Okay, it doesn't predict whether this is going to be a plus sign or a negative sign. You have to do the real measurement to get that number. Okay, do you get it? All right. Okay, so this is the part that I didn't really talk about, and so let me go back to the reaction one more time, okay? And I want you to tell me, when you run this reaction one, do you remember what was the reaction temperature? This reaction right here, do you remember? Let me see.
Was the question about the reaction temperature?
What was the temperature of the reaction?
It is in the ice bath, so it is 0 degrees Celsius.
Thank you. Thank you, Carissa. It's ice bath, okay? And so, why do I want to point out this? Let me close this. Procedure right here. You're doing this reaction at 0 degrees C. Because you're running acid-base reaction, am I right? And you want to minimize the side reaction. Remember, this biggest side reaction was number one, self-attack of the amino acid, am I right? Number two, it is the acid-base reaction between the anhydride and then NaOH, okay? Right here, let me tell you, anhydride, this is anhydride. And then the NaOH, okay, this is the acid precursor, okay? Look at this, they react each other, okay? If you don't control the addition always make this sodium hydroxide limiting reagent, then you have a side reaction. So in order to minimize it, okay, we want to add sodium hydroxide in small portion at, in five additional sequence. And then you can minimize the side reaction between the two. You also minimize the self reaction of this amino acid, okay? So the ice temperature not only controls this reaction of the desirable direction, the other thing is at the end, you are adding sulfuric acid to protonate all the species, remember? Okay, and that is a big acid-base neutralization reaction. And tell me, based on your common sense, this acid-base reaction, exothermic or endothermic?
Exothermic.
It's super exothermic, okay? And you're using a strong acid, am I right? It is the 6N, that is 3M, the strong acid, not only a strong acid, it's a strong concentration. So when it enters a solution, it releases the heat, let alone the acid base, neutralization also creates heat. So in order to minimize the temperature, you have to have the ice, in order to minimize the side reaction, you have to have 0 degrees C control, okay? I want to point out this because I want you to compare the reaction condition of the forthcoming part 2. Okay, just briefly browse this paragraph, okay? We will be running this reaction, okay, under, oh my goodness, you want to flame dry the sample. You want all the glassware free of moisture, so you know, hey, the moisture is gonna be back, okay? Attacking one of the reactant, or it will cause some side reaction again, okay? And I want you to browse the temperature for reaction by reading this paragraph right here. Okay, so from this second paragraph, you're doing the workup. But here, do you see the temperature of the reaction specified or not? Does it tell you, do you have to heat it up?
No.
No. Does it say you have to keep it in ice?
Also no.
So is the temperature of the reaction specified?
No.
No.
No. So what do you think the temperature of the reaction is?
Room temperature?
Thank you, Carissa. I want to give you 1 point, okay? Yes, this is a reaction at ambient condition, okay? Why is that? Because we want to mimic human body temperature, to tell you the truth, okay? This is a potentially a, you know, peptide reaction. We are actually trying to build protein, am I right? We are trying to make this, look at this. You're trying to make a new amide group. Okay, it is a peptide because this is a peptide. This amide group come from peptide reaction. If it is amino acid and then carboxylic group, we call it peptide, okay? It is a special kind of amide, it is peptide, okay? And this is another peptide, okay? Because it's coming from, hey, basically amino acid. Oh, you probably don't see it. I want you to see right here. Did I ask all of you to write down? This is actually chloride minus and NH3 plus, and I call this ammonium. Okay, so this is amino group, but it's acidified version of it. Okay, we want to make sure this amino group does not cause problem, a side reaction during storage. Okay, so the vendor provide the amino group this way. Okay, and this is ester group, so potentially, okay, once you hydrolyze it, it will turn into COOH, okay? So we just wanna, okay, this is probably like a small, it's like a molecule from a protein that has a functional group of an NH group available from a protein. Okay, so you want to develop a drug. How about that? Okay, this is like simulating a drug reaction. Okay, you create a new drug and you want this new drug molecule to either, okay, activate or deactivate the protein from your body. This is probably an enzyme, okay, with NH2 group available. Okay, and this is a long chain coming from this way. Okay, and yeah, it could be amino group from one of the protein. And so you have to understand when people develop new drug, a lot of the reaction is to have this molecule of a drug to react with the enzyme in the human body. Okay, so imagine this is an enzyme, long chain from here. Okay, NH group is available. Okay, so this drug can react with the enzyme in the body, maybe inhibit some undesirable reaction, okay, that the enzyme is capable of catalyzing. Okay, it's probably along that line, but of a reaction that people designed the drug for. Okay, so why do we want room temperature? Because once you take the drug, once you take the medication, you want this reaction to kick off at ambient temperature, mimic to your human body temperature. Understand? Okay, so look again, right here. Okay, this is the peptide bond formation using TBTU, okay, and you want this reaction to proceed ambient condition to mimic the body temperature, okay, and you want this drug to work at room temperature, and see how long you allow this reaction to run. Are you able to see it? How long do you want the reaction to run?
Two hours.
Hey, this is going to be your pre-lab due next week. I want to give you a little bit flavor of what you're doing, okay, for part 2. You want to do it for 2 hours, am I right? So ideally, hey, how about take the medication and then the reaction started, okay, right away, and then it will take effect in 2 hours, okay? Let me see who's responding. Chat. Can I hear you? No. Andrew, I cannot hear you, okay? All right. All right. So besides talking about this room temperature being the condition of the reaction, I also want to point out right here, TBTU. I want you to look up what TBTU is from the literature I uploaded on Beachboard, okay? This is a big coupling agent. I would not call that a catalyst because this particular species actually breaks apart during the reaction, okay? And this is a promoter of the reaction. Without this molecule, this reaction will not proceed at room temperature, okay? And just give you some basic common sense. Having this carboxyl group reacting with amino group and forming a peptide. This reaction usually requires higher temperature, beyond maybe 200 degrees C, in order to get this amide group. Okay, so unless you leave it like years and months of reaction time at low temperature, or else it's really hard to get this peptide, okay? I mean amide group. And for this reason, okay, we need this TBTU to help initiate the reaction at room temp, okay? And what does TBTU stand for? Okay, go ahead and look up the word, okay? The term U right here, uranium salt. And this uranium itself has a lot of nitrogens, a lot of CM bond, double bond, single bond, okay? CM bond. And it's a big weird molecule. It's not a catalyst because it does degrade during the reaction, okay? And it's not regenerated as a intact molecule, okay? And people spend a lot of time, okay, designing this molecule to make this reaction work at body temperature, okay? And so a lot of effort, and this, I consider this part 2, reaction part 2, the Rolls Royce of the whole 420 training, okay? In the first part of the reaction, you review a lot of general chemistry. Okay, it is really nothing special about that reaction, but part 2 is high fashion. This is high fashion, the Rolls Royce of the chapter, of the whole 420 chapters, okay? All right, and so besides this, why am I getting so many signals? Oh, this is coming from my own, okay, other platform, social platform, don't worry about it, okay? And what else do I want to point out? Okay, uranium salts, a lot of nitrogen, I didn't mention it. Okay, let me keep going. And any questions so far?
Yes, can you hear me?
Yes, I can hear you now.
Oh, that's a relief. Okay, the TBTU is added in excess, right?
Look at the quantity here. Look at the quantity.
Where?
674 grams.
Okay. And it's being stirred and mixed for 2 hours.
1.05 equivalent. So you are adding it in a small excess, yes.
Okay, and then we're letting it go for 2.5 hours so we can confirm that it's
2 hours.
Or oh yeah, 2 hours so we can confirm that it's completing the reaction, or to make sure that all the reactions react to yield a specific amino acid.
From this quantity given, we just want to make sure, you know, in the lab, we're able to produce decent amount of yield and for you to characterize the product. I wouldn't say it's 100% completion. I wouldn't say that, not at all. In fact, the yield from reaction 2 in the range of 50%.
Okay. Also, when I was doing a research on the side reaction, it was saying that there is a chance that there wouldn't be a side reaction because the side reaction is normally inhibited by the slight excess of like carbonyl compounds and related to the coupling reagents. So basically in a short period of time, those carbonyl compounds would inhibit like any side reaction from happening because of how much carbonyl groups is
okay,
like
let me tell you this. You have a very good point right there, okay? Yes, we didn't cause big side reaction here on the carbonyl group, okay, here or here. However, there is some other side reaction. Okay.
Oh, that's not a relief.
That's not relief, okay? Now, for this side reaction business, we're just using this one point to promote you to scholar level of thinking, okay? Don't kill yourself. Once you think outside of the box, and you train yourself to think outside of the box with this one point of incentive, you will build that habit whenever you read any reaction in your whole life, okay?
Yeah, but I was trying to think like what side reaction could be possible in outside of like the first side reaction that we wrote in the first pre-lab.
Hey, Andrew.
Yeah.
You really over-engineer the whole reaction too now. Remember I said this is a moisture-sensitive reaction?
Mm-hmm.
So did I give you a hint long time ago? If it is moisture-sensitive, then write the reaction of the something react with moisture, it will do something different.
A hydrolysis reaction.
Well, go ahead then. Okay? I like it. Yes. Hydrolysis on this ester. Is that possible? Yeah, that's definitely possible. Okay? And how about water mingle with, I don't want to tell you more. Okay?
Yeah, I just sometimes in organic chemistry it's hard to like write. Like I always think about hydrolysis reaction being possible, but I know that in organic chemistry that water is like supposed to, let's just say it's equivalent to the devil, I guess, because you're not supposed to have any water reaction in organic chemistry. That's the exact opposite of what you want, because it would literally just, it would like send you backwards from anything that you're trying to actually create.
Okay. Water is the devil. You're right. Okay. In a lot of organic reactions that I've learned so far, number one enemy, moisture. Number two, oxygen, the air. Okay. And so one time I think I had a conversation with Dr. Nagayama, and I was worrying about, Dr. Nagayama, I found a lot of glassware. Students can't really clean up their, the round bottom flask to 100%, free of residues. And I don't know really how to advise my students anymore. And you know how he responded to me? And I laughed, okay? He said, Jean, it's better to have a dry and dirty flask, glassware, than clean but wet. Yeah.
Yeah.
Carissa, ask your dad. He told me that. And I laughed the whole day, I can tell you. I was worrying about nothing. Okay? Moisture is, a lot of times, number one enemy, okay? Moisture and oxygen. I'll say in the industry I come from, I have been in the petro industry for a long time, okay? And oxygen is just another devil. I hate it. And so a lot of times you just keep the reaction under a nitrogen atmosphere, okay? So running chemical reactions is not it's a lot of details involved, okay?
Yes.
Yeah, and we want you to learn to pay attention to this detail in order to be a good scientist. Understand?
Yes.
It means a lot to the yield. Okay, you guys can play, hey, yield is just a matter of doing calculation in the lab, okay? Oh, the theoretical yields 1 gram, and then I only got 0.3 grams, so it is 30% yield, okay? You look at the yield that way, but me, I come from industry, and I supervise on board. I can tell you what yield means. It is just cost. It means profit margin, okay? And so changing it to from 30% to 40%, it means a lot to the cost, okay? So moisture, yes, by all means, please, we want a flame drive for a reason, okay? So go ahead and write reaction, whatever Andrew is good proposing hydrolysis. Yes, whenever moisture is there, there is a potential hydrolysis somewhere, okay? And go ahead and think along that line, okay? Am I okay now? I think this is a good training. You're all getting the flavor. And
is there a possibility?
Yeah.
Is there a possibility that say if part 1 didn't fully react, like say if we didn't in part 1, if we didn't connect that carbonyl group onto the N-terminus on all of them, is it a possibility that we have some product as a self-annealing product in the second reaction?
Well, remember you actually collect this by recrystallization.
Mm.
You remember that, right?
Yeah.
Not only you target pH 1.0 and you eliminate all the
Oh, the targeting of the pH is confirmation of like a specific
yeah, you already
yeah.
make sure, yeah, all these protonated, okay, and all the base being killed. Then you can wash the acid by rinsing the crystal using water. And this is as much you can do. You know, after you rinse everything, all the particles with water, and you're able to recrystallize. I can trust that. I mean, most people get melting point close, really, really close to the literature value. I mean, I'm happy. Okay.
Mm-hmm.
So you're saying there could be some impurity here, proceed here?
Yeah, I was thinking like, okay, but that makes more sense because we have pH targeting, we make sure that we have a specific confirmation. My question was like, what if we didn't? Because even in part one, we could have had some of those. We could have had some product that didn't have the carbonyl group added to the N-terminus, and then in part two, if we didn't have a pH targeting, it could have some product in your final product that had self-annealing.
I can tell you this anhydride part, when you say extra carbonyl group, you're referring to this anhydride, right? It falls apart with so much base. You remember you add base in large.
Oh, in excess, yeah.
Yes, you killed it all. Yes, okay?
Mm-hmm.
Yeah, this is strong base. It will not be lenient and leave the anhydride alone. No, I don't think so. They fall apart so easily, okay? Okay, that's why you introduce the base in a very small quantity at a time.
I get it now. The Chatelier principle.
Yeah,
Mm-hmm.
I want all of you to pay attention to this, such a detail. It's just one paragraph, okay? And I can tell you, you and I will, I think you are reading the procedure just as close as I am now. Okay, I read procedures carefully. I will pay attention to every word that is mentioned here. Okay, yesterday some student asked me, there's a word talking about the purification right here. There's a word, big word right here. Right here. Right here. I want all of you to look it up. Triturate or triturate. You want to triturate the oil with diethyl ether to obtain the crystallization process. To begin the crystallization process, that means you want the crystal to form. Okay, I'm so happy students are asking, you know, the detailed terms about the procedure, because it means you care about what you'll be doing. Okay, so this word is meaning that you are changing the polarity of the solution in order to make the product precipitate. Okay, remember, I don't know, oh, we didn't do solvent removal under rotovap.
In order to,
We didn't have time, right?
For
But
the Aldol?
we did it with the Orner-Emmon reaction, right?
Yes, we did.
Okay, yeah. Remember, the solid actually remain as an oil sometimes. in the residual amount of solvent. Sometimes even without, without recrystallization or without precipitation, you're already required to proceed and recrystallize the product in the oil, in the oil solution. Am I right? I think some of the students did, they were not able to obtain the product in solid crystal form. They only got oil, the oily product. It is because a lot of times the crystals cannot sit tight together because the viscosity is too high in that oil solution. Now, when I say oil, it means, in the presence of some other solvent, okay? And if this is the case, if you encounter such a difficulty, go ahead and dissolve this compound by adding a little bit hostile, hey, that means unfriendly, at the solvent with a different polarity to force the molecule to precipitate. Okay, for example, if you think your molecule is probably nonpolar, and the solvent happen to be friendly to such a molecule, okay, and make it dissolve. So it doesn't matter how hard you try, you try to precipitate the desirable product out of the solution, you can't get it, you cannot get it, because the solvent seems to like, and the solvent molecule and the desirable product molecule seem to like each other so much. What you can do to change that friendship, all you can do is introduce some solvent with, how about high polarity, and force the molecule to precipitate out. Understand? And this is the word triturate is referring to. Do you get it? You want to introduce a solvent with a totally different polarity in order to make it hostile solution to the desirable product. When I say hostile, means it is going against the like dissolve like.
Wait, say it again.
Okay, let's say you remember the like dissolve like principle.
Yeah.
Okay, molecule of high polarity will dissolve in solvent with high polarity. Molecule with a low polarity will dissolve in the low polarity solvent, right? Because the same kind of polarity, they like each other and solvate the desirable product so well. Am I right?
Yeah.
Okay. All right. So the intermediate level polarity molecule dissolve very well in the intermediate polarity solvent. Am I right? Because like dissolve like. So high polarity likes high polarity solvent. Low polarity product likes low polarity solvent. The intermediate polarity will like intermediate polarity solvent. Okay, and a lot of times it so happened that the solvent you chose for the reaction or for the process is just perfect. They are a perfect match in the polarity, okay? And so the product does not want to precipitate because the solvation, they dissolve each other so well and refuse to form crystal. In order to form crystal, you have to make sure the molecules of your target molecules wants to sit tight together. That's called precipitation, am I right?
Mm-hmm.
Okay, so how do you force the molecule to sit tight together? The only thing you can do is make the solution add some other solvent that has a different polarity to force the molecule feel that, hey, I'm not in the comfortable environment anymore. I would rather sit tight together with molecule of the same kind. You get it?
Yeah.
Okay, so this is the word, okay, triterate is referring to, okay, you're just adding a solvent with a different polarity and to make the solution hostile. It's not a friendly environment for your end product to dissolve in anymore. It's hostile. Okay, so it will force the molecule to sit tight with each other. And this is how you precipitate a target product. Do you get it, Andrew?
Yes.
Good. All right.
I was writing it down. Sorry. Yeah.
Let me tell you, this word, it looks just one word, right? But if you let yourself go easily, oh, I don't care. Miss Jean, you tell me, or else I don't want to learn. I can tell you, any chemist, if you see any strange term mentioned in the paragraph, you should look it up, okay? All right. Other than that, I think I covered enough for reaction 2. Any question at all?
Trituration also remove impurities too.
William, can you repeat it because your voice is breaking up?
Oh, sorry.
And can you speak close to the microphone?
I'm wearing headphones. I'm not sure. Can you hear me?
I can hear broken voices sometimes, though.
Okay, I'll switch the mics. And give me a sec. Is that any better?
Yeah, I think a bit better. Go ahead.
Okay, I asked, does trituration also remove impurities?
Oh, yeah. If you precipitate the product, then you can collect the crystal by suction filtration, right?
Yeah.
Yeah, yeah, yeah. It's actually purifying it at the same time.
Yeah.
Yeah, you're able to, yeah.
Yeah, it's almost implied that it removes impurities, because when you have something that you're isolating and you force it into crystallization, then that means that the rest of what's not being crystallized is easier to get rid of. So
Yeah.
Yeah.
It does. It gives a little bit purification there. Yes. The purpose is actually twofold. Kind of, I can call it twofold. Okay. Okay. And I also want you to look at the optical rotation data right here. Okay, this is the product coming from part 2, okay? And my goodness, this is a long name, okay? This is the reaction product of part 2, okay? This is the bipeptide. Dipeptide, that means 2 amino acid together. All right, and I want you to look at melting point. Do you see a big difference right here? The LL and then the DL. Did I talk about this, your starting material, L or D amino acid for the reaction part 1 right here? Did I talk about this stereochemistry does not change during this process? Did I tell you that?
Yeah, you told us last time.
I wrote it down. I did write it down in the handout. I uploaded it as a Zoom topic on the first day. Okay, I want to tell you that if you have a D starting point, you end up getting the D product. If you have an L starting point, then this is the L product. The stereochemistry does not change in part 1. Okay, stereochemistry conserve in chemistry reaction 1. Okay?
Is that for all? Like, is
I
that
have
for?
not finished yet, Andrew.
Okay.
For part 2, it's not the case.
Okay.
Okay, you know why? Because this coupling agent will do something. Okay? Okay, for this reason, TBTU as a coupling agent is not desirable yet for the drug molecule synthesis yet. Okay, if you ask me, Ms. Jean, why do we learn organic chemistry at all? I can tell you, with good organic chemistry knowledge, I'll say at least 50% of the organic chemists will target to build new drug molecule. Okay, and once you get a drug molecule work safely in human body and effective in human body, you're talking about that reaction or that know-how, that patent will be worth $1 billion normally. Understand? Okay, and people are trying so hard to inhibit some enzyme in the human body by doing this, model reaction using the TBTU, but unfortunately, the stereochemistry do not conserve. It only conserved 50%, but it failed the other half. Okay. And so look at this. At the end of part 2 reaction, okay. Look at this. The only difference is, hey, it says my connection is unstable. I'm sitting right next to the modem. Anyway, do you see this melting point being different? And I want you to see also right here, the optical rotation. Now with this change in the direction, okay, look at the difference in the optical rotation. Okay, when the molecule gets big, that light enter and then bends in the weird manner. Okay, and I just want to tell you that. Okay, this is often encountered in the bioorganic synthesis. Okay, so far so good. Are you able to do the pre-lab? I think you can now, okay, with some introduction knowledge. Explain to you, I don't want you read this article with fear. I want you to imagine, hey, what if you were the one designing the, the drug for COVID-19, okay? And this is probably step 1 for you to inactivate the virus. Okay, just target some the function group, okay, available on the surface of that particular virus, and then you can inactivate it by running a chemical reaction. You never know, okay? You all have that potential, okay? So am I done for now with the peptide? I think, let me see. Oh, there's one thing I want to show you. Hello. The peptide reaction flow charts. I can tell you, yeah, the training from the side reaction is a big step for, young chemists. And this flow chart writing is another training for young chemists, okay? And I want to show you my writing from part 1A. I better do it this way. Can you see it? Are you able to see it? Hello?
You can see the lab
Yeah.
manual.
All right, and go ahead. Do you see this molecule of your amino acid and hydride, and you add sodium hydroxide? And during the procedure, you create, the protective group attached to it. You generate acetate and the 2 molecules of water being created. Are you able to see it?
Yeah.
She's showing us her camera, so you have to leave the share screen.
So you can swap it to up in the top right-hand corner.
Hey, I actually turned on the video already. So
No,
what do
yeah,
I
but
do?
I just didn't know what you were trying to show us, so I was still looking at your computer.
Oh, I'm clicking
Yeah,
start the
we can
video.
see you. We can see you.
No problem now. Okay, so one more time. Okay, reactant. Okay, product in the salt form, water as a byproduct. Okay, and go ahead, you protonate it using sulfuric acid. Then you get this, and you get neutralization product. And this is water soluble and water put together. Acetic acid dissolve in all these, no problem. Then go ahead, filter. Okay, some of the final product from reaction 1 contaminated with some amino acid, you recrystallize it. And others just go to the filtrate. Okay, let me tell you, part 1 is easy. Okay, the only trick is the pH business. pH 1 as a target. But let me tell you, for reaction 2, wow, I would say it's probably more complicated than this, okay? And I want you to learn to pay attention to the details. Wait a minute, am I back on the screen now? Are you seeing the screen?
Yes.
Yes.
Okay. All right. Let me put this back. Okay, this is the procedure for reaction 2. I want you to look at the word, hey, dry, okay, so, this reaction is moisture sensitive, right? Okay, dimethyl, okay, formaldehyde, okay, look it up. Okay, try to understand, because we are running amino acid reaction, and with amino acid, there are a lot of nitrogen, so I can tell you, in this reaction 2, there will be a lot of nitrogens too, okay? Coming from the reagent side. And even the solvent here has a lot of nitrogen because like dissolves like, okay? Now this is quite nasty though. If not, I think this is carcinogen. Yeah, very nasty, okay? And you will see this Clayson adapter. Go ahead and draw that apparatus on your notebook, okay? Go ahead and see how, this whole assembly for the reaction should be set up. And okay, now this is your starting material. Hello. This is actually the product from reaction 1. The N-protected amino acid. This is your product from the reaction 1, okay? Then you continue with, okay, adding, we call L-alanine methyl ester hydrochloride. So what is that? It is this molecule. Okay? And we actually block the COOH. This is probably another amino acid, but pretend this is, I already synthesized into a molecule as an enzyme molecule in your body. Okay, this is just a model reaction right here. Okay, for the human body when the drug takes effect. Okay. All right. So far, so good. I can tell you, if you ask me, Ms. Jean, what is your favorite reaction of the whole entire semester? I will tell you this part 2. This is my favorite. Okay. It's high fashion, Rolls Royce of the whole 420 training. Okay. And at the end, we do provide you in the lab manual, the NMR data. Okay. And to be honest, my students last year were able to produce decent NMR also. So this is amazing. When you see students with that capability, their instructor really feel proud. You know, we feel encouraged when students perform with you know, good results, because you have to do everything right to come that far. Okay, every single step you do, you have to be disciplined enough. You have to understand to deliver that result. Okay, and so I can tell you the Aldol spectra you're getting from my Monday, Wednesday section. I can tell you everybody did a good job. Okay, the only difference in those spectra were just maybe the amount of the contaminant, which is the ethyl acetate. But you know, the J3 constants coming from the doublet of doublet, all very nice. Okay, and so I was amazed with the with my students in lab sections. You know, both lab sections. I'm really proud of you. All right, any other question you may ask now? And
Yes.
yeah.
Another question.
Do you happen to have the grades from the quiz that we took?
Yes, I have the grade. I have the grade. In fact, the first day when the class was canceled, that was the day I was scheduled to show you your quiz, in-class quiz. I should give you the sheet, but I cannot let you keep the sheet, understand? Yeah. So my recommendation will be during the spring break, okay, when I finish grading your pre-lab of peptide 1, okay, I should say reaction 1 of the peptide experiment, I should be able to finish the Orner-Emmon reaction, okay? I should be able to upload your grade book, your grade up to this point. And if you want to see your quiz in the class, I suggest that you schedule appointment with me in the fall. Come to my office, I'll show you. Okay?
Mm-hmm.
Are you gonna post the grades though?
I will post the grade up to this point. After I finish grading peptide 1. I actually did one section, okay? I didn't do your section yet. And the Orner-Emmons reaction, I have not started grading yet. We're all too busy, tell you the truth. Yeah, during the past 2 weeks, I was in middle of crisis. It's just too much work, okay?
Do you know if overall there would be a little more leniency with your grading, and not just your grading, but I'm talking about with Dr. Lopez grading as well, since like everything's online and like it's just very different. I'm not used to online classes or anything like that. This is a way different experience for me.
You know, the problem is everybody has the same difficulties, okay? Do you think I like to teach this way? No, I don't. I hate it, okay? But the thing is, in terms of grade, we're told to give a lot of consideration that people are not receiving the same quality of teaching from instructors. And every instructor, every professor on campus received the same a notification from the president of the school, okay? So don't worry about it. We just want you to show the same hard effort, okay? And I think we're pretty much in the middle part of the semester now. You just need to know where you stand, right? And the thing is, with the Aldol report and the peptide report forthcoming, and the Greenyard reaction, that is another one. And then the oral presentation, I would say that is probably more than half of the grade assigned to this semester. Am I right? And so it is Dr. Lopez that will have to give the consideration how he wants to issue the grade at the end. I only report what the points I collect from the students. He will make decision on the passing grade. Do you get it? And yeah, I can only do my part. Okay, I really don't have the overall control over your grade. No, I don't. Okay? Yeah, your job is just to make effort and then pump all the information out of me. The only thing I will not do is I will not give you answers directly. We're not told to give you answers directly, okay? Yeah. We're not allowed to give you free answers, in other words, okay?
Yeah, of course.
Yeah. And other than that, I think I'm a little bit worried about this Aldol report, to be honest, because you need to do the formal report format. And I told you this is a big deal, right?
Wait, say it again. We need to do what?
Formal report. Do you know what that means?
Not really.
Well, have you had experience reading Journal of Organic Chemistry?
Oh, yeah.
Okay, I can tell you that format alone is a big deal. Please read the instructions carefully. Okay, in the lab manual will tell you. We already tell you what to watch out for, okay? It's not easy. It is not easy to write professionally. You don't say, I added this reactant. You don't say I mean, there's no such a thing. You don't mention yourself, okay? This is called professional writing. You're like a reporter now. Okay. Hey, I hear no voice.
Yeah.
I have a question.
Okay, please.
So it's with the NMR spectrum for our report. I know Dr. Lopez posted them.
Which one? Which one? Aldol, right?
Yes.
Yes.
He posted them, but he didn't assign it to us. It's just for the section 4.
That's not true. Okay, my instruction will be for you, okay, because we already gave you, the spectrum, which is coming from the straight benzaldehyde or the other group. I think we gave you 12 spectrum, right? We give you 12 spectra, and 6 of them were not zoomed. And so half of the spectra we gave you were zoom spectra. The other half just full scale.
Yeah.
And then in that zoom, well, I mean, for each compound you're assigned to do, go ahead and pick the better spectra, a spectra pair.
Okay.
Is that okay? I remember, yeah. I remember, George, you did the straight benzaldehyde, right?
Yes.
And I remember Carissa did the para, or right? Carissa, you made the para-methoxy.
It was the meta.
Oh, you have the meta.
Yes.
But anyway, I mean, we gave you the spectra, and we tell you which pair were the meta, which pair were the para, right?
Mm-hmm.
Yes.
And just between the two, pick a better one. Okay? You should be able to write a report, no problem.
But we're still starting with our same starting materials. Like it's
You know, on my grade book, I did write down who was doing what. Okay,
perfect.
I still have it. Yeah, so I know where you're from. Okay, that's actually just one little thing on the IR and one additional peak assignment on the IR maybe or NMR. No big deal. It's just one extra peak.
When
And
we
for IR, yeah, because the methoxy group on the aromatic ring, yeah, there is additional CO bond, right? And there should be additional peak coming from the methyl group. That's it. What's the big deal? Just no big deal, right?
yeah.
Yeah.
When we reference the materials that was given to us,
Mm-hmm.
do we just put according to like?
You just write down Andrew. All you have to say is I was assigned to do the Aldol product of the straight benzaldehyde. I remember.
Okay.
Wait a minute, right? Are you doing the straight benzaldehyde? I guess you did.
Yeah, I'm doing straight benzaldehyde.
Yeah. So all you have to do, yeah. And I don't think you write the report based on 3 molecules. I don't think so. I don't think so.
No, I'm just saying like all of the evidence that you guys give us is given. So like when you're using given evidence, like you have to cite that the evidence is given. Like
that's right. You just need to, you choose the one, choose the pair of the spectra that helps you write the report. That's it.
okay.
So would we be analyzing both of the spectra that's given? Because there are two. There are two.
Yeah, there will be one full spectra, the other one's Zoom, targeted at the doublet. The diastereotopic hydrogens, remember?
Yes.
Yeah. That Zoom is for you to determine the J3 constant. Also J2. Yeah, J2 and J3 can be determined. Am I right? And I can tell you, the students from Monday section, they did a good job. I mean, everybody was able to show me the doublet and doublet. Everyone, yeah, good job. So just pick the cleaner one, because I think for each compound there are 2 groups doing the same. Okay, but the level of contamination may be a little bit different. You can see through. Okay, it's just extra peak coming from ethyl acetate. That's it, right? Okay. Anything else?
What is the analysis report sheet that it mentions at the end of the report of the?
Just report the theoretical yield, and then you can say the actual yield is 0, and we all understand you will not be penalized, okay?
Oh, okay.
Yeah. You're not going to be penalized, no way.
I'm sorry, can you repeat that part? I couldn't quite hear it.
Oh, sorry. The actual yield is 0, but you can still present your theoretical yield.
Oh, yes, okay.
Yeah. Tell me, is this online teaching affecting the quality of the knowledge you receive? Does it really affect it?
There,
It has its positives and negatives, especially when it's a class like this. It is very informative, and I like the knowledge that we're receiving and the theory side of it, but I am still a little down about how we can't really get the hands-on experience.
Oh yeah. You know something? I agree with you, Carissa. I can tell you a student, actually a group of students already wrote to me. 2 questions. One of the question is, Miss Jean, should I just retake this class? Okay, someone asked me yesterday. And they were saying, I really like this training and I don't want to sacrifice the hands-on experience. And so would you recommend that I retake? And I said, if you really want to be a good chemist and you regret that you lost this opportunity of hands-on, my suggestion is go ahead and join a research group, okay? You will get this training in the lab every single day, okay? The 420 training is just appetizer amount of what you need to do compared to what you need to do in the research lab. Okay, when you're training students in the, and it's the same as I call it cooking, okay? If I give you the same recipe of chicken and you cook it every day in the kitchen, your cooking skill will be so different than just, you did it once in your life.
Right.
Yeah, it's the same. Okay. So in order to polish up your hands-on experience, your observation, how you make decision at some critical points, okay, during the process of a reaction, etc. Gosh, go ahead. If you really like it that much, go ahead and join research group. Okay, you'll learn to pay attention to every single detail. And right now, when I read this procedure right here, okay, just from this first paragraph right here for the reaction 1, you would not believe me, Miss Jean, when I studied it the first time before teaching this class, I actually had maybe more than 50 questions written, okay, on my own notebook. Okay, what happened here? Okay, what if this happened? What if that happened? Okay, I have thousands of questions in my head. Okay, and this is what we call the training. You wonder, hey, does it really work? With pH down to 1.0, am I really able to precipitate something? I mean, you will put the question right there. But in the lab, if you work long enough, okay, you realize you will ask a whole bunch of questions associated with details. Okay, this product should begin to crystallize. And so, okay, so how does it look like? Is this gonna be a fluffy? I can tell you, in fact, this product is like coconut. Have you seen coconut powder? This is it. This is, it is like coconut powder. So in my imagination, when I read it, I was thinking, hey, this is probably a particle powder. Okay, like starch powder. No, it's not. Okay, and so is it easy to handle a melting point measurement? It is not. Okay, so when people grind it, okay, it is not just regular pulverizing anymore. I ask students to use a mortar and pestle. It's stuff like that. Okay, I can tell you just a lot of details involved. So to answer the student's question, if you really like hands-on experience and you want to be a good chemist, of course, you should join research right away, okay? And of course, I welcome you. If I teach in the fall, I welcome you to come to my lab and observe what needs to happen, and the part of fun you missed.
So that's an option too, to
I
visit your class?
I offer that. I offer that to my students.
Oh, okay.
Yeah, well, you're welcome. If I teach this class, you're welcome to come to my lab and witness what needs to happen.
Okay.
I will keep that in mind. Thank you.
Yeah.
I wanted to add to the questions that you asked, which I think that online like learning is very limiting in this type of class, because a lot of chemistry comes from like learning. It is different. Like there's sometimes that you like give a lecture in the beginning of lab. Like I've read the lab, I wrote the pre-lab, so I understand what I'm doing. But you know, those small things that you have a question about, then when you go over it in the lab, you're like, oh, okay, it clicks. But it doesn't actually click until you produce something. And you're like, oh, okay, I really get what just happened.
Exactly. There's
It
no
solidifies it.
replacement. There is no replacement for lab work, okay? No way. The lab training itself has to be in person.
And error analysis is one of those big things that comes with chemistry. And just like the idea of making a mistake, like having a teacher like you and Dr. Nakayama, like you guys are so rigorous that like when you're in class, none of the students want to disappoint. We've came such a long way. So that extra applied pressure is very good for us, because when we do make a mistake, it make us question what our mistake was, which is a great form of error analysis. And I think that that's very important for the class. But as far as learning from this experience, I think it's not a bad idea for like maybe in the future for teachers to incorporate a 1 hour, instead of having just an office hour, the teacher can have a 1 hour open discussion like this on the weekend, or like on a Friday, or I would say the weekend, like a Saturday or something, or or sometime throughout the week. Instead of just having office hours, you can offer a 1 hour open online moment like this, where you can go over to the lab or go over it in detail, because some of the questions that people have as they're reading can be answered, and they can come to lab with a greater understanding. This is an opportunity to learn from. I think there are some of the things that you said on here that is like perfect, because I'm the type that I just keep thinking, like I can't stop thinking. So like I read into things too much. So when I got a chance to leave, like I read a lot of the stuff. That's why I was asking you very different questions, and you answered them, and it's very eye-opening. I think it's a good experience.
Oh, I'm very impressed with your question and your request, okay? In fact, I complained to the course coordinator several times. My Monday, Wednesday, this 3+3 lab format, I didn't really welcome it, okay? We have no choice. If I were to teach the Friday, I think I can find 1 good hour of quality time to go over the mistakes students already made, or whatever. Like after reaction, we need to review, okay, and talk about the potential, I should say, correlation between the mistake and what you see in the end result, okay? A lot of times there is correlation right there, okay? Mm-hmm. And oftentimes I just give you guys a warning, and then students are able to avoid that mistake. But actually, being a good chemist, to tell you the truth, making good mistakes is actually good. But the problem is, in 420, we cannot afford to give you another opportunity to just make up this 6-hour experiment, understand, and allow you to make mistake. That is the problem. This is why research lab training, okay, is important. That when you're in the kitchen every day, you will be different, okay? You can make good chicken, believe me, okay? Learning from your own mistake, okay? It's learning curve cannot be built without making mistake, to tell you the truth. You think I can teach without seeing students' mistake? No, I cannot. And tell you what, every time I right after the class, right after the lab section, I will write down the mistakes, and I'll write down how to explain that to students in the future. Okay, this whole process, I just enjoy it myself. I mean, because I work in the factory for a long time. Okay, so everything, little thing we mentioned here, it just means a lot to the yield. Okay, why we design procedure this way? Even, you know, stupid thing like, you know, ice bath for the first part, and second part you want room temperature. There's always a reason, okay? And it's just a lot of details. And for you to think along that direction, I really appreciate it, okay? I will only complain that this 3+3 format didn't allow me to give you that review session. I call it a review session, how about that, okay? For us to go over what happened last time. And only when you're doing the research, you have that opportunity to brainstorm with your supervisor, okay, with your research advisor. And on a daily basis, you can learn from your supervisor. This is so different. It's going to be like intensive training of your hands-on experience. And I can tell you, didn't I say several times, if I were trained the same way as you are in 420, I could have been a different person. And unfortunately, when I was an undergrad student, we didn't have such a class. We didn't. It was not offered to us. Okay, and because the funding was limited, no way we had this independent lab drawers do, you know, some complicated reaction and talk about fancy theory. No, we didn't have the money, okay? And if I were trained the same way, I told many people already, I could have been a different person. I probably don't want to join industry. I probably just want to join Nobel Prize winners lab. I probably feel determined. I think I can handle it. Yeah, and I want to learn the best. Okay, so try to appreciate, yeah, and please ask questions. If I know it, I'll give you the answer. If I don't know it, I will really appreciate you giving me that question so I can study and dig into it, okay? Yeah. Go ahead and challenge me, okay?
Yeah.
Okay. Anything else? Now, I'm not trying to, you know, brush you away. I want to make sure all the important things are covered, and I need to make sure you're able to do the Newman projection, etc. And besides that, let me see. Yeah.
I had 2 questions.
Yep.
For the Aldo report,
Yeah.
will we just report or for melting point, will we just report the literature value and then say we weren't able to take the melting point of ours?
Right. You can just state the literature value, no problem.
Okay. And then my second question was, do you know what's going to happen with our lab drawers? Because I think I can't remember whether or not a bunch of my test tubes are in my
30?
benchmate's drawer.
let's not worry about that yet. You know what?
Okay.
I remember Dr. Lopez sent you guys a notification. Hey, come take your personal belongings.
That was a little last minute. I was not able to go.
Yeah, that was very last
So,
minute.
Yeah, I'm in San Diego.
I did the same to my students. Okay, no one has any clue how we can handle this matter yet, and we're not worrying about that yet. Okay, we're not that far yet. Okay, as long as you're not leaving a dynamite or powder in the drawer, we can care less now for now. Okay.
well, I care because it's my lab coat.
Yeah. I think I will suggest this to our department. Okay, maybe we can allocate one day in the summer or before the fall semester. You guys can pick up your own stuff.
I talked to the two that works in the laboratory. I'm in the stockroom at the school, and they said what they would do is when school starts back, they'll go in and take inventory of all the stuff that's in the drawer, and then they'll code on to all the lab coats, the goggles, and everything, and they would try to write down the drawer that's associated with. Or if they don't have time with that, they're just going to hold a big time that everybody can come and get what's theirs or see if they know what's theirs. They won't have time to specifically contact every individual that have a drawer and see what's inside of them, because
we will have a master batch of like personal belonging pickup day, right?
Yeah.
Okay, that's good. Master batch. But the thing is, what is left in the drawer? This is what we're concerned about. As I said, as long as you don't have a TNT in the drawer, we don't worry about it now.
I was working on something similar.
You have a gunpowder left in the drawer, and that will be explosive, in the summer. And don't worry, okay?
Yeah.
Okay.
And by the time when you come back, I think your Aldol product is already dried.
Mm-hmm.
Am I right?
Yeah.
It's supposed to be your pure Aldol. Am I right?
Yeah.
Yes.
So save it as a souvenir then.
Would you also be responsible for cleaning the stuff in our drawers if we had like a mass pickup day?
No.
No. We only have an informal checkout day. Okay. Yeah. In other words, you don't mess around with changing the locker, etc. You don't. But in the regular semesters, I do ask students to clean up everything, every little test tube, etc., and make sure even the lining, the paper towel get replaced. Okay, so when people of the new semester come in, they open the drawer, it's a brand new drawer. I always want to give students, I always want to discipline my students that way, okay? And unfortunately, we're not able to do that.
Yeah. According to the people that work in the stockroom, anybody that's going to be charged for anything that's missing so far, for what they know right now, if you're only going to be charged for what you've already have broken and taken out before the lockdown.
Good.
They don't, as of right now, they don't know the extent of anything that's possibly missing or anything like that. So they won't further know what will happen until later. Like I'm in communication with them because, I work in a personal lab. I work in a research laboratory, and we order things all the time. And we have a lot of orders and shipments coming in. And so I need to communicate with them in order to store those properly, because we're talking about very expensive things here. And so I communicate with them every single day. Plus, they're my friends. Yeah. So that's all that we know so far. They can only do so much because they have direct orders that they have to follow too, outside of what the president of the school say. They have to follow strict regulation rules also. So this is all they know so far. They haven't released any of this information yet because it's still, a lot of it is still undecided, but this is what they came up to. Like this is
Good.
like, yeah.
Good. Thank you for the
Okay.
feedback.
Thank
Yeah.
you.
Thank you.
Yeah, no problem.
Thank you. Yeah, yeah. This is like running a factory. Our issue room, I know a lot of times we complain about them. We cannot really support our need constantly, minute to minute. But when I sit back and I have to say, this is the group of people that is most abused. I'm using this word, abused, okay? They are being abused by the school. I can tell you that. With limited manpower, they have to handle thousands of students. Is this fair? Tell me.
No.
No.
It's not fair, okay? So I can see some of the individual already burned out.
Mm-hmm.
Mm-hmm.
And I cannot blame them because they have been abused, okay? And the thing is, every time when the funding is issued to the college, okay, even though they can request more manpower to support them, good luck. They cannot find anyone to really do the job in order to call this person a support or a help. It's hard to train that person.
I see.
Yeah, it's really difficult. I mean, I work in the factory. I know. Okay, this issue room is basically a production center, or all the resource. Okay, for how many classes you tell me. Okay, and so many different kind of needs coming from that one room. I have sympathy for them. And so whatever they say, we follow, okay? It's not the other way around. It's not that like for them to follow our order. No. If they don't provide us the dry ice and we cannot run the rotovap, we can point fingers. Yeah, they didn't get that dry ice in place. But anything beyond that, we have no reason to complain, okay? Let me put it that way. Let's be thoughtful. Let's be human. Okay.
Mm-hmm.
Yeah. I talk to the chairman of the department occasionally. Okay. I told him basically, if it doesn't hold up my whole class, that means I don't want to get people going and all my students are ready for the rotovap and then dry ice is not there. Okay. Then I can tell you I have a reason to complain. But anything beyond that, I know it is the structure of the department or the structure of the college that screwed them up. No, in other words, it's not the employee that they deserve the blame. I wouldn't point fingers at them, no. Okay, they have been abused too many years. It's unfair.
Mm-hmm.
Yeah.
Okay, it's unfair. Let's try to be human. So I even encourage my students, if you owe them a favor, please show some gesture, friendly gesture to them, okay?
Mm-hmm.
They will understand, okay? Is that good?
Yeah.
Yes.
Yeah, we want that attitude in the society, okay? Don't complain. If you initiate a positive gesture to else, you realize the atmosphere just changed right away for you.
Oh, yes, absolutely.
Yeah, be positive, okay? And so I always tell my students, okay, I know I'm not perfect instructor. I know, I admit, okay? But don't complain. At the end, I hate you. You tell me now what you need, okay? You don't say I hate you at the end. Does it help you? No. Does it help me? No. Okay. You understand? Yeah, let's try to be positive, okay? If you think I can do more to help, let me know. Yeah.
We appreciate what you do, Dr. Lee-Lin.
Really? I don't know. Did I do anything unusual? I hope I did help. It's really hard for 420 students to see, for you to prepare yourself to the level that I think you can handle the work independently. I can tell you there's a huge gap, okay? We can only try to assist you, but it's still from you, from within yourself, will have to want to learn. If you have this attitude, hey, unless you tell me or else I'm not gonna find the information myself. Hey, if you have that attitude, I can tell you, you don't belong to this class, or it doesn't matter how I teach, you won't hear it. Yeah, I noticed this is actually a mentality problem I need to handle more than, you know, just sticking the knowledge or, you know, equations to your mind. It is not that anymore. It is from within. You have to want to learn or want to review. Stupid things like pKa, okay? Go ahead and take a look and you will understand why amino acid will have to be written that way, okay? With the Switter ion, etc. You get it?
Yes.
Yes.
Okay? Yeah, so take this opportunity as a brush up of your, you know, understanding of Chem and all the fundamental and all the fundamental knowledge associated with this, you know, chapters. You know, good review.
Dr. Jean, will you be posting this recording on Beachboard?
Okay, that is a good question. Is this who's asking? Adriana?
Mariana.
Hannah.
Mariana.
Okay. Okay, I try to upload it. Well, tell me, any recording like this, is it worth posting at all?
Yeah.
Yes, it is.
Really? Okay, I'll do it. Okay. The only time I don't upload, it has to be a problem associated with the quality of the recording itself. Okay, I was not able to do that Tuesday discussion. Remember, I actually lectured the first time to you
Yes.
guys? Yeah, I was not able to do that because the internet, as I explained right at the beginning, the internet reception was just no good. Right after, it is during the time, you know, when I finish the Zoom discussion, I'm supposed to convert the whole file to MP4, okay? And during that conversion period, it should be only a matter of 2-3 minutes. My internet didn't work. You get it? So it showed me a big sign. And then later on, I you know, when I check the recording, it was only 1 minute showing in the file. So I decided not to upload it. Understand? But for today, I will upload it.
Thank you.
Okay, would it help? You think it will help, huh? Okay, I'll do that.
Yes, thank you.
Okay, and I think next week is going to be spring break. And I will still take short questions by email. Okay, I would not have time. I can tell you next week is my big week of grading the reports. Okay, I will have to, you know, get the grade book updated, etc. So I don't plan to give a long discussion, but I can answer short questions by email. Okay?
Yes.
Will you post a recipe next week or a video or a picture of something you cooked?
For chicken?
Yes.
Yeah.
Yes, please.
Are you serious?
Yes.
Yeah.
Yes, very.
Okay. I didn't really cook chicken recently, but I'll post something else. Okay.
Instead of a chemistry blog, can you also create a chicken blog?
You know, but the thing is, my biggest problem is all the recipes I have, a lot of them are just, a lot of the recipes were written in handwriting and maybe some Chinese mixed in. Okay, I mean it's Chinese characters, and
I see.
some of the recipes are really scratchy. I mean, when and you know, unless I retype it, oh my goodness, that is a lot of work for 70 recipes. Okay? And actually, I inherit probably 20 or 30 recipes from one of my a chef, a friend who used to be a professional chef. Okay, and so yeah, he gave me this the recipes, and he because I enjoy their cooking. Also, in the past, I had nanny when my children were small. I hired a chef with 3 chef license, Indonesia, Singapore, and then international chef license. Oh my goodness, talking about her cooking, really, really awesome. And so I paid 50% more labor charge to her because of her cooking. And let me tell you this, yeah, it's, you know, now we can relax a little bit. The you know, the chef, just by observing how she cut apart chicken, okay, when she came to my house, she complained, Jean, all the knives you have in the kitchen, just they're just useless to me. Okay, so
they're not sharp enough.
They're not good enough for her to do her job. Okay, so so I brought her to the department store, and then she picked the of course the Henkel brand, the real Henkel brand, and then she showed me, you know, when the chefs to get their license, they had to pass so many tests, and one of the tests was to cut up the chicken, and they said they were being timed. Okay, under how many minutes? We're using a matter of 2 or 3 minutes. They have to dissect the chicken. Okay, into, you know, the portion according to the specification. It's just amazing. Just look at how they. So you're right about, you know, the lab training. Okay, it doesn't. I mean, she's not genius. Okay, it is all coming from training. You do it every day. You're good. That's it. All right, and then you can create the recipe, you know, by observing the difference when you change the formulation, you know, increase the temperature. When you add, you know, sumac, okay, the chicken will taste this way without the garlic or with garlic, and where acidity increase. You know, it is the chemistry part you can play later after you do, you know, you discipline yourself, get the training step by step. It is the same as OChem. OChem is equal to cooking in the kitchen.
Yes.
Am I right?
Mhm.
So did I tell you when I worked for BP, that was my first job. And I have to tell you, this is a real story. The plant manager, I call them plant manager. Actually, they are president of that site with, I think, 1,000 or 1,200 employees on the site. That when this president retired from this BP, you know, production site, 2 president, you know, 2 terms. I'm talking about the president retired, and then the second president retired. They all went to chef school after retirement.
Oh.
Can you imagine? Yes, it is chemistry that make them want to learn how to cook in the kitchen. It's just amazing. These 2 things, you know, just closely correlate to each other.
Mhm.
I hear that from other chemists as well, including my dad.
Oh, including your
Yes.
dad. I can tell you. Yeah,
There
yeah.
are similarities.
Yes. And my research advisor at USC, because this is where I got my degree from. Okay, I can tell you, my professor was able to serve a banquet for Thanksgiving. So every year we go to his house for a celebration of Thanksgiving. And he was able to serve the banquet. I'm talking about banquet, okay? Just all chemists are born with that talent. And I happen to be the same. I realized I like chemistry because I enjoy cooking.
Mm-hmm.
I see.
Or vice versa. So you tell me, students, okay, if they work in the restaurant, I always ask them, where do you get your raw material? Which supermarket you go to for this kind of fish, for that kind of fish? I usually take notes, okay? It's funny, right? Yeah, I enjoy cooking, okay? And you tell me if I can find, the quality of steak from this supermarket, even with a little bit higher price, I'm willing to drive 1 hour, no problem. I will get that steak. Okay, this is what we do. I mean, one of my weekend activity, just food hunt, okay? Yeah, if you want to eat good food, you follow Miss Jean. You're right. Yeah, so yeah, we wait until the end of semester, we can celebrate better, okay?
Mm-hmm.
How about that?
Yes.
Maybe, summertime, yeah, it's summertime. Yeah, let's see if we can still keep in touch with each other.
I'm looking forward to it then.
Oh, okay. I'll bring my puppy. Where is she? Yeah. She left. She heard something.
Oh.
She left. Yeah. Okay. Is it good for now? Everybody? Everybody? Are you happy?
For now, yes.
Yeah. Okay. I'll see you after spring break then.
Yes, thank you.
All right. And enjoy. All right. Enjoy the hard work.
Thank you.
Bye.
Thank you. Goodbye.
Bye. Bye.